AI, intuition.
This is the moment of revelation. On one hand, we have node analysis, a core tool of electrical engineering. On the other, we have our incidence matrix, an object of pure mathematics. Today, we perform one final operation that will connect these two worlds forever and prove that they were never separate at all.
Welcome back to the moment of truth. We have our KCL equations from node analysis, and we have our incidence matrix A. Let's find the connection. The first step is to take our matrix A and find its transpose, which we call A transpose. This simply means flipping the matrix, turning the rows into columns and columns into rows.
The next step is to introduce the vector of currents, which we'll call y. This vector simply contains all the unknown currents from our circuit's branches.
And now for the single most important operation of this series. Let's multiply them together. A transpose times y. Let's look at the very first row of the result. When we multiply the first row of A transpose with the vector y, we get the exact same equation as the KCL equation for node 1.
And this is true for every single row. Each row of the A transpose times y result corresponds exactly to the KCL equation for each node.
This means Kirchhoff's current law, which states that the sum of currents at each node is 0, is mathematically identical to the equation A transpose times y equals 0.
And as we learned in our previous videos, the set of all vectors that solve an equation like this is called the null space of A transpose, or as mathematicians call it, the left null space.
This is the profound revelation. The set of all physically possible currents y that can flow through a circuit is precisely the set of vectors that live inside the left null space of the matrix that describes that circuit.
AI intuition. So node analysis is the left null space. The set of all possible currents in a circuit is the set of all vectors in this beautiful mathematical space. But what is the structure of this space? What does it look like? The answer lies in the loops of our circuit, and that is the final piece of the puzzle we'll explore in our next episode.
Subscribe.